Hi everyone, this is Anna from Math 5A, and this is my first project where I will be overviewing what we learned in week 1 and week 2 of Intro to Calculus and Limits. So first, Intro to Calculus. I think as a non-math major, math might just seem like a bunch of numbers. But actually, calculus allows us to see that we can actually have almost like an X-ray vision where we can actually see into the math numbers and have an image of it. And so an example would be the area of a circle, right? So for the area of a rectangle, we can pretty much see it pretty clearly how to get it. But for a circle, you might wonder, well, how did we get the formula? Or why is the formula pi r squared? And so it's really cool because these ancient mathematicians, they broke it up into like different methods to how do we find it. And so one of the methods was this triangle method where they kind of made it into like a rectangle, and through that they were able to find the area using this triangle method. And another method that they used, which I thought was pretty interesting, was like they dissected the circle to make it into a bunch of rings, and when they unfold these like curled up rings, it turns into these straight lines that we can actually put into like a table. We can actually see the more lines, like the more rings there are, it actually begins to look like a triangle. And we just plot it in where like we understand that this is the outer edge, which is the circumference of a circle, and then this is the like cuts, the radius of the circle right here. And if we just take the formula of a triangle, half times the r times the circumference is 2 pi r, we actually do find that we get pi r squared. So this is how the formula comes about. And so calculus is really just almost like an imagery where we can actually see we can see it being beneficial, because when we see things, like we have a different perspective of life, that we can actually like calculate the exact number through like dissecting it, or like do these calculations. So yeah, it can actually be pretty fun. That's something I learned. But let's go into limits. So limits is such an interesting concept, and basically the main point of a limit, understanding it, is if you have a function, right, and it's an open interval containing numbers like a as x or l, we can see that the limit appears if, this is the most important part, if x approaches a and the limit of x approaching a of the fx is l, then we can say that there is a limit. And so what that kind of looks like is, let's say you have an a value right here, and your x approaching a, you see that your graph, it meets at this point right here. And because it meets at this point here, we can get a y value right here, which is the limit. But what if there's a hole right here, right? So the concept of a limit is, even if you don't actually reach there, because you get close enough to this singular point, you can say that there's a limit. And so what that looks like in mathematical terms would be the limit as x approaches a to the function is l. So you might wonder, okay, now we have a limit, but how do we evaluate the limit? So there's two methods to evaluate a limit. There's the table formula, and there's graphs. And so for the table, we would use Excel, and we would choose a set of numbers that are less than a, because we can't approach here, right? And we can't really touch here, but we can get really close to it to decide like what is it, and we can get a set more than a right here above a, and that's how we would use the table. And for graphs, we can actually use the app called Desmos, which is pretty cool, to kind of graph it out for us, to make life easier, you know? So here's an example. We look at the graph. So let's look at function f, like x, x squared minus 4 over x minus 2. So easily, if we just look at this, we can kind of see that, you know, at x equals to 2, we substitute this 2 minus 2, we would get 0. And if the denominator is at 0, we can clearly say that this function is undefined, right? But, you know, if we make this statement and we don't give any other details, we don't really get to see the function. We don't really get to understand it. But that's why we introduce the concept of a limit, and we can draw and see the graph. And so this is what the graph looks like. And we have the line here, and right here we identify there's a circle, like an open circle, which means that it doesn't touch there. And so we pull up Desmos, right? This is really cool. And we just type in the formula, the function right here, and we can get this line right here that they draw for us. So we can actually view it as well. And approaches too, they didn't put a circle because it's kind of like they estimated that it was there anyway. They just connected it. That's why it's so important for us to understand the concept. And for Excel, let's do it together. So for Excel, we're gonna open an Excel sheet, and we're gonna type in the function. So we want to type in the function so we can see what it is. So we have x squared minus 4 over x minus 2. And so from below, we want to get as close to 2, right? So we can use x minus 0.1 or x minus 0.01. And so by minusing that, we can get 1.9, 1.99, and 1.999. And so how would we do this in Excel? So you put your equals sign, and you can't just like put this in. That's not how it works, the function. You have to substitute your x. So the way to substitute is you can take this, click on this, and power 2 minus 4, and then over your number again, which is D4, minus 2. And so by doing this, you can get your answer to this equation. And so as we continue it, we can drag this out like this, and we get the formula. We get the answers, okay? And so you can do the same thing from above. So this is what you're going to be doing for other functions as well. And so this is our function, and from above it would be 2.01, sorry, 2.1, and 2.01, and 2.001. And same formula, we're just going to apply that. Gonna apply the same formula. Power 2 minus 4 over D4, F4 minus 2. Okay, so now we got this. And you know, from this, we can actually see it's approaching the number 4. It's like getting really close to 4, but not there. So that's why we can conclude, even from this graph as well, you see this is getting close at 2, it's getting really close to the number 4. So we can say it like this. As x approaches 2 from either side of 2, the values of y, f function x, approach 4. Therefore, we say that the limit of function x as x approaches 2 is 4. And the way we write it out is limit as x approaches 2 of the function x is 4. Okay? And so now we're going to understand two important limit laws. So there are two important limit laws. So it's very interesting because as we can see, limit x approaching a to the function x is just a, and a is a real number. And the limit x approaching a to a constant c is just c. So the way this works out is just like how we did that function, right? We had limit, and then we had like our x squared minus 4 over x minus 2, right? But let's say this doesn't become that, and we just have x, right? And we substituted it as 2. Well, if our x now we substitute as 2, well then we can clearly see that our limit is 2, right? So that's how we get this kind of limit law. And the same concept goes for c a constant. Right? Remember, if let's say our y is just a constant number 1, and it's just 1, right? So as the limit from x approaches a, as it approaches, it would just be this number 1. So we can even draw it out as a table like this. See, even if you get really close to a, you're still going to get c. You're still going to get that constant. So these are two important limit laws that you can use to your advantage when you're doing algebra, or when, So the next topic that I want to go through is one-sided limits. So as we saw from this one, it approached the same thing. But, seeing this next graphs, we can see that this doesn't approach the same thing. We can see that, this is approaching 0.1, and this is approaching the number 1. So there's two limits. But how can we write that out? So there's such thing as a one-sided limit. So there's two types of limits, limit from the left and limit from the right. Okay? And so essentially it's the same thing, function and an open interval and real number. But the difference is that where x is less than a, approach the number a, then we can say x approaches a from the left. And the way we symbolize that is a negative sign from the left, right? From the negative values or negative sign. But then from the right, it's essentially the same thing, but x would be more than a, right? And it's from the right. And we symbolize that with a plus sign. So these are the two types. And so let's try to do this together. So evaluate each of the limits for the function x plus 1 if x is less than 2, so we know that's from the left, and x squared minus 4 if x is more than or equals to 2, so from the right. And so this says from the number 2, as x approaches 2, x approaches 2 from the left and from the right. So how will we do this? Remember, the way to evaluate limits, there's two methods, table, and there's also graph. So let's try the table method. So if we take the table method, we're going to go into Excel. And now our function, we have 2, right? We have function x plus 1. And we also have a function which is x squared minus 4. These are two functions, okay? So now to do it, we can do from below. And the number we're getting close to is 2. So x, so we would have same thing, 1.9, 1.99, 1.999, right? And we substitute this in when our fx is x plus 1. So how will we do that? We just equals to this plus 1. And then we take this and drag it down, and we can see our values, okay? And then from above, we would get x and our function x. Same thing, 2.1, 2.01, 2.001, and it would be equivalent to this plus 1. And we get 3.1, and it's approaching the number 3. And so now we're gonna do the other side, right, which is this one right here. Let me see if I can do this. So that we don't get confused. And then we have from below, same thing, x, function x, right? And we have our x value. We're gonna use the same thing, 1.9, 1.99, 1.999. And then we also have, the way we would do this would we would have x squared minus 4. This is what we get. Okay? And then from above, same thing. And what do we get? Oops, it's kind of lagging right now. But you should get a number very close to 0. Okay? So since we understand that the limit of this one, of the function from the right is 0, but this is 3. They're not the same, right? So we can actually conclude it by writing something like this. Ta-da! Okay, so based on this table, we can conclude that the limit from the left is 3, and the limit from the right, as x approaches 2, is 0. So therefore, the limit of fx does not exist, and we represent this by dne at x equals to 2. And then same thing from the graph, we can say that the limit of the function x as x approaches 2 from the left is 3. So the graph, a rough sketch, you would kind of see something like this, okay? So you would have a straight line, which is the x plus 1, something like this. And remember, it's less than 2 when we get this. And then the other side would be something like this. But, you know, you also have a defined point here because it's also equals to 2. So that's kind of what the rough graph would look like, and that's how you can evaluate the limits. All right, thank you.